My name is Piyush.
Piyush? Okay, cool. Nice to meet you. It looks like you're gonna be the first one to go.
Yeah,
Um, okay. So I'll just give you like a brief overview of the problem, and then I'll give you time to read on your own and then ask me any question. So
sure.
ultimately, your problem is you're gonna be giving a source, target, and a string of words. I mean, array of words. So in this case, this is Python, right? Okay. So if your source is bit to dog, you have to find if there's a way, like the minimum number of steps you need to change from bit to dog, um, by going through this words. What that means is that you can only change one letter at a time.
Mhm.
So from bit, if there's a word that you can change one letter to, in this case, but, but
Yeah,
is a word, and then also big. um, And so you have two words, right?
yeah.
Like, okay, cool. That means that you can move forward. And then now you have to see, all right, let's just say big is not in here. Let's just say, or like what is not here, just big. Let's
Okay,
just say this is not in. Well, actually, big doesn't lead you to an answer. So let me just take that away for now. Um, okay, after that, you can make one more change from but to see if there's any word in the array that you can change one word to that will bring you closer to dog. Anyway, in this case, from but to put, you can change one word, right?
mhm.
And then from put, you can change from put to either um, to pot.
Mhm.
And then from pot, you can change one word to either pog or log. But let's say you change it to pog. And then from pog, you can change one word to dog.
Okay,
And then you will finally get to your target. And the total number of changes we just did is 5, and you have to return that. So I'm gonna give you some time to kind of like, and if there's no way to get to the final destination, then you can just return
minus.
-1. If there's a way, then you just kind of keep track of your transitions and return the shortest amount. There could be two ways to get to the same dog. Let's say, then you want to return the shortest one. So take your time and read through examples and take it from here.
Sure, sure. Thank you for explaining. Let me just read the question once more. So, given two words, source and target, the list of words, find the length of sorted series of edits that transform source to the target. Each list edit must change exactly one letter at a time on each intermediate word and each intermediate word. Okay, so here it is saying like the target word should be present in the list of words, right? So if it is not present, then I can outright put like, okay, this is not possible. That is the one condition. Then it is saying like I can only change a character, single character. Um, like for each transition, I can have only one change. So for example, bit is given, then I can change either B or I or T, right? So mm, yeah. So then there is no two. Hmm. So now here I have to worry about like what transition to choose from, so that I can have a path for the next word. Because for example, if I choose something like from but to bit to big, then maybe I've changed only one word, but then what I change next, right? So for example, if I
Exactly.
bit to big, then then I will be out of IG. There is no IG elsewhere, right? Or there is no PG elsewhere, so I will be stuck here. Okay. So the brute force approach could be, um, so basically, I can start with any character, right? So for example, I have a source. I can start from there, and then I can see like which words, which all are the possible words that I could transition to. So for example, for bit, it could be but, it could be big, or it could be, but that's it, right? So yeah, that's it. So these are the two possible possibilities. So I have two pathways here. So then I can choose either one. So let's say I choose bit from bit to big. Then if I go again from big, I could not find anything else, right? So I can return from there, and then I can choose the second path, which was but. And from but then I can see like what all are the possible ways I can, what all the possible changes I can have. So it could be put, or it could be uh, there is only one thing here. So but in the worst case, like it would be like I'm doing a brute force, wherein I am going through all the possibilities, right? All the possibilities that I can have, and then I am choosing like and here it is no constant, like I have to give the minimum or maximum, right? So oh, it's the shortest one, right? So I can have the track of the shortest word, track of the length of changes that I took. So if there are multiple possibilities, then I can choose the minimum and I can return it. So this is the brute force approach for this.
Okay.
So is this the intended time? So time complexity will be exponential here. Um, so is this the intended solution, or we should think of some
Um,
better approach?
so are you using depth first search or
Yeah. So DFS will be used so that I can iterate over all the paths, right? And I can check like so I can recurse back and check for the other uh,
Mhm.
possible paths. And
So how do you make sure you don't encounter the word again?
so
So for
there
example,
will be a scene array, right? Which I can maintain for a particular path. And
okay,
if in this path, and if in that path I already used the word, then I cannot go to that word. So then I have to exclude it. And
okay. And you said the why is it exponential? Why is the time complexity exponential?
because for each, so for example, I started with bit, right? So for but and big, I am trying to traverse like twice, like I'm trying to traverse whole array, right? To check whether which all words can be next possible path, and then for that I am trying to traverse whole array minus like all the words I have already used. So so it's like n square for every word. For every word I'm trying to see all the words and then check whether I can move forward or not.
And how are you checking if it's bit and but, for example? How do you know?
Okay.
So you're saying for every word you're looping through this one time, and then
Yeah.
for another word you're still looping through this, and then for one time looping through this. Isn't just that n square only, like you said?
Yeah.
Um, but I guess um, for every word and you're looping through this, what are you also doing with each of them?
Yeah, for that I have to, traverse each word also. Uh,
Okay.
and
Yeah.
then I have to check whether it is like only plus one change, or, it's so it will be another n added to it. So it will be
Okay.
like
Yeah.
O of
So
n
you
cube.
can call it k, like the length of a word. So yeah, n times k to the second power, like
Yeah.
square. It's
N
correct.
squared
Time
k. Yeah.
complex. And then your space complexity is
Same. So space complexity would be, actually, it would be order of n, because I will be maintaining the scene array, right, which can have maximum elements that are in words. So suppose all the words are used, then I would be having that many elements in my scene array. Else it will be like reduced and then filled once again as soon
okay.
as I.
I think that's fine. I think so. There are two ways to go about this problem: depth first search and breadth first search. And their recommendation is breadth first search. And when I solved it, I also did depth first search, basically what you just said.
Okay.
So either one, it looks like they both have like average, like similar average time complexity. But usually, I think people recommend that if you're ever trying to find a shortest path, use breadth first search. Again, I'm not too comfortable with breadth first search. I mean, I should be, but I don't know. Well, I always just go to depth first search because I think recursive solutions are a little bit easier sometimes.
Yeah.
Sometimes. So up to you. If you want to, I don't know which one you're more familiar
I
with.
can go with like I can code both. So let's try with breadth first search. I think so. In breadth first search, basically it will be like something like I will be creating a tree, right? So I have a source element which is bit, and then for the second level I will choose like what all path is present. So it will be like button big, and then I can iterate over button. Then I can see like what all path are present, and then I can move forward for that.
Okay,
So
sounds good.
so let's try. Let's see like if it is okay. Hmm. So basically, let's have a queue, right? So the queue will be having all the elements currently in the under consideration. So in it, let us put the source one, source word. So this will be our root from where we are starting, and then basically what I want to do is I want to pick out this word, and then I want to put all the words that are in the next level, and so okay, I also have to maintain the scene area. Hmm. So in this scene area, like just to save some time complexity, I can just put the index there, um, and basically it will be easier to check. So is my tuple. Uh, so while queue, till my queue is there, and also I need to maintain a distance, right? Or what is the total number of transition that I have took? So it will be basically zero at first. So let me so while queue, let me take out this then. It will be like source comma c, and then the dist. It will be queue. Right. So now once I have the word, then I have to iterate over the words. And if it is like in the one distance, so minimum distance is one in between them, then I can push into the second level itself. So for that, let's write a function, right? So def find diff, and this function will basically return true or false. So it will have a source, and um, let's word one, word two, right? So for C, so all the words are of same, length, or it can be different.
Yeah, it could be different. Yeah, checking, doing a quick return if they're not the same, obviously.
Yeah. So return first.
Well, I guess if they're not the same, technically,
You can have one difference. Yeah.
yeah, so maybe not.
I think in this question, like they all should be like in the same, character length. But yeah, that's fine. Just putting a check there. So for range, There is a zip function also, I can use that, but yeah, it's fine. Mm. Right. So this particular function will go and check each character, and like it will count it. As soon as I pass one, I will just return false. As if the loop completes, it will return true. So
Okay, so
forward in words. Um, so if find diff s comma word. So if this is true, then that means that could be my one possible solution. So q dot append. So I will be appending this, right? So q dot append. The source will be like word because this will become my next source. Um, so I can append scene. Okay, scene dot append this particular word because I've already seen it, and then the distance will become +1, right? Here I have to add one more check. So if word not in scene, right? So I don't have to check the difference also if I've already seen that particular word. So yep. Okay, I can have some answer thing, which will be basically minus. Let's initialize it with -1 itself, right? No. So let's initialize it with maximum because I have to find minimum. So infinity and okay. So the if my s is equal to, so this is my terminating condition, right? So if my s is equal to target, then I will be updating my answer. So minimum of answer comma dist. Okay, let's see. So basically, what I'm trying to do is I am trying to create a scene array, scene set, right? And basically, I'm trying to maintain a queue which will have these three things. So it will be having source word, then scene, and then what is the current distance right now. So I will popping out the word. Then I am looking at whether the source is equal to target or not. So for example, the source and target are same, so it is like zero, right? So the answer will be zero. Else for word in word, so I will be iterating all the words here. I will be checking like whether the word is in the scene or not, right? So for example, okay, so this is not C, right? So so here the scene is C. So if it is like if I have not seen this particular word, I will go and find the distance. If it is uh, is equal to 1, right? um, then I will append that word because I have already seen it because I'm adding it into the array of this particular thing. And once I've done this, I will increase the distance because I've added one more word in the tree, right? So now my distance has increased. So once I've completed all this, the answer should contain the minimum distance. Uh,
Okay. What if you don't have a minimum distance and you never find anything? You have to return -1. Wouldn't it
yeah,
currently?
yeah, correct. Yeah, I forgot about that. So if answer, so if my answer is untouched, then it's like -1.
Awesome. And here, should it be SE, like because of this? Or
Oh yeah, sorry.
I think same here too.
Yeah, I am bad at naming.
No,
uh,
it's okay. I know you. I understand. That's like super small, so it's not a big deal. Um, I think maybe you even like do it so that you don't even have to assign answer float, if that makes sense. So I mean, is this like a normal practice? I mean, I think that this looks good. But first of all, I think it's fine. It makes sense to me.
okay.
You can do a drum run if you want to, but I feel like you explained it really well, so I feel like I understand.
Mhm.
Up to you. You can do a dry run with the examples, or you can just run the test. Whichever.
Uh, there is some indentation error. Oh, this actually. Let me just remove these comments.
Okay,
Basically,
sounds good.
see, it was just the comment. Uh, okay, so let's. Do you want me to do the dry run, or should I just directly run the test?
Hmm?
Do you want me to do the dry run with the sample, or should I run the test?
I feel confident, so you can run it if you want to, or you can do a dry run, whichever. It's up to you.
Okay, let's run it just to. If it is fine, then we can move it. No, not fine. Actual is undefined. Okay, undefined. Oh, oh, sorry. It's add. Yeah, it
Yay!
passed. Yeah,
Wow, you're super good. Good job.
yeah, thank you.
Um, yeah. Okay, so I don't think you should even try depth first search because I think this is like good enough.
Yeah,
Uh, and this is actually very similar to the op that they gave you. So, all
yeah,
right.
but in this, I think like I've used more space. So I like I'm storing everything, right? So maybe it can be optimized for even better space. But yeah, for now, I think it's fine.
Yeah. I mean, you could. I mean, like you could just add like all the words in a set to begin with, and as you're moving, you can delete the word from the set or something. Like, and then your set doesn't have that word
Yeah,
anymore.
because I'm high, because I'm moving as a tree, right? So I don't have to process that word again and again. So
Oh, right. You're right.
yeah,
And I think this is fine because I think this is your answer is exactly what they gave. The only thing that they did differently is instead of assigning answer like this, right? They just um, they just went ahead and like if s equals target, you return the depth, and if you
yeah.
haven't returned it at the end, you just return -1. So you don't have to do the step of assigning it to float.
So how are they then having like minimum path? Because they are in the question, it is like shortest word edit path, right? Oh, okay. Because we are doing breadth first search, then I will always find the
Fine.
shortest one first. Yeah, 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 yeah. That's cool. Yeah.
Okay.
Okay.
Awesome. So that gave me a little bit more time to work on.
Let's swap the roles. Yeah.
Okay.
Okay.
All right.
So
Go
do you
ahead. Do you want to
wanna?
explain?
Yeah, sure. So basically, in this particular question, you are given an array, right? And the range of the integers that can be in this array is from 0 to integer max, right? And what you have to return me is the first non-negative integer that is not present in the array. So for example, in this particular thing, right? So 0, 1, 2, 3 in the sample. So if you can see like 0, 1, 2, 3 is present, but 4 is not present. So 4 is your answer, right? So if in just in case like the one was not there in this particular array, you would have returned one, right? And the integer can be, so it can be like 100 also in this particular array. So it is not like it is bound with the index, right? So the maximum number in the particular array can be more also. Did
Okay.
you? Yeah.
Yeah. Okay. So if I understand correctly, to repeat what you said, you're saying that I have to return the smallest non-negative integer.
That is not present in the
And
array.
that's not in the array. And the array is guaranteed to contain is it so I have some questions about the array. Is it always consecutive, the numbers in it, or it could
No,
be like
it can be anything. Yeah.
it could be 100? And can the array have negative numbers?
No. So it is given like the range of the numbers is between 0 to integer max.
I see. Okay. Um so what I'm thinking is, right, like let's say 0 into integer max, so it could be like a million, whatever.
Yeah.
And is it sorted or not really?
It is not sorted. Like, it is not given. Yeah.
Oh, okay. All right, that's good to know. So I could have like 3, 0, and then 100.
Correct.
Um, so what I'm thinking about doing is, right, and then I see that I cannot modify the array.
Yes.
Um, okay. So and then it looks like they want me to be efficient. So I feel like I'm gonna try to see if I could do one pass. So what I'm thinking is here, right? If I find a number here, every time I'm looping through it, if it's a um, unless it's 0,
Hmm.
I guess um, if it's 3, the smallest non-negative integer, the possibility right now could still be. So I guess the largest number I've seen so far is 3,
Hmm.
and smallest candidate could still be 0.
Okay.
It will start off as 0.
Correct.
Um, let's say I have like 2 and like 6. I don't know. I'm just gonna make some more example, and then I move on to the next one. Um, The largest number is it greater than the largest number? No. Is it smaller than the smallest candidate? No. So I just like move on. It doesn't make any difference, I think. Um, I don't really care for because my answer is 1. Um, hold on. Yeah, let's say I don't keep track of that. Um, and then oh, it cannot be 2 anymore. So I guess this is like my top like sorry, wait, let me think. My top range almost. I don't know. So maybe this should be 2. Well, actually, no, sorry. Let me just go down this path and see. Okay, what if I just keep track of largest than 3? I think this algorithm might be full of flaw. If I go here, it's 6. I don't really care that it's 6, but I guess I can keep going. Um, and if it's 7, then I guess I keep going. And then this is smaller. Is it smaller than or equal to no smallest candidate? If I find it here, I need to increase. Yeah. That also doesn't work because my smallest candidate is 0, and I just saw that. So I need the next possible one is 1. If I've seen 1, let's say I see 1 here, then the next possible candidate cannot be 2 because I already saw it.
Yeah.
Um, hmm. So in this case, my smallest num should be like 1, 2, 3. It should be 4. So um, let's see. How can I do this differently? Maybe I don't keep track of largest num. Um, do I do smallest candidate is 0, Or okay, so like I guess the way I'm thinking is I always start with a possibility of it being like 0 to something, right? Like I don't know what, and then I feel like it will shrink as I go along. If that makes sense, like my range not shrink. So if even if I find 100, it could still be 101. So I don't really care for the largest number per se. Um, so let me think. So out of all of this, could be up to 100. Then my possibility, if I have something like this, it could be anything from 0 to 100. So if I see 3, my smallest candidate, um, it doesn't really tell me anything. If I have 3 in here, I just know that it cannot be 3, but it could be 4 or 2, or something greater than 4, or something greater than 3, or something less than 3. But it can be 3. Um, you know what I mean? So when I'm here, I almost divide my like potential. And this is not necessarily consecutive, so it could just be a bunch of numbers like this, right? 100 and then 2 and then 5.
Yeah, yeah,
Um, let me see. So when I'm here,
okay.
my range.
So before going to the most efficient approach, can you just tell me like what is the basic naive solution for this, like the brute force?
Okay. So I guess I go through the entire array. So if it's 3, um, I would like probably put it in a set or something, or well, actually, what is the brute force approach? Um, so let's just even if I use the example, if it's 0, it cannot be 0. It must be 1. It's not 1. I already saw 1, so it must be 2. When I'm here, no, it must be 3. Here, this is 3, so it must be 4. I'm at the end of the array. The last, um, but here, so I just loop through, and then I'm just checking each time. Here, it's 3, so I guess it must be. I would think that it's either 4, or I guess I can check against this array. Could I have 2 pointers? Um, and I check to see. I mean, if I can sort the array, I'll probably sort it and go to the end.
Yeah,
But I cannot sort the array. So
you can, right? You can create another array, sorted array. Like you are not modifying it, but you are creating.
that's smart. Yeah, I could slice it and like sort that, and then I would just take. So once it's sorted, I would let's say if this gets sorted, this becomes 0, 1, 2, 3, 6, 7. And if it starts with a 0, then it's kind of like this now, where um, if the initial is 0, like I can have a counter, like
Mhm.
minimum starts at 0, and if it hits 0, then it's fine. I increase this by 1, and if the next person is the same as minimum, that's fine. I keep going,
Mhm.
and I increase this as well. If it's still the same, I keep going, and if this is obviously one, it's different. So here, after this, I'm at 4. And if this is greater than that, I just return this. And this would be like my minimum. So
Yeah.
this would be like n log n times n. And
And login
yeah,
times. And what is the time
n log
complexity?
so n log n to sort the array. And
Uh,
then I have to go through the array once. But I guess we drop the we drop the ones that are not dominant. So I think time complexity would be n log n.
okay. Yeah, that's
Even
correct.
though I have to go through the array one more time, but it's like
Yeah,
kind of
and
constant.
plus n login. Yeah.
And space complexity, I guess I'm just creating another array the size of n.
Yeah.
But
Yeah.
so now I guess should I try to improve it.
Yeah, reduce the time complexity. Maybe the space complexity can be same.
Um, Sorry, what?
So I'm saying like just try to reduce the time complexity. Maybe the space complexity can be same for now.
Okay, like create another array. Um, okay. So improve time complexity. That means don't sort it. So
Mhm.
I have this array, but I can use another data structure to help me store things. Um, and I'm always struggling with array questions. It,
It's fine.
it,
It's fine. That's why
so,
we are here, right? To practice.
yeah. So if I cannot sort it, well, how can I make use of another array or maybe another map? Um, I mean, I could add everything into a map, actually, a set.
Mhm.
So I will have a number of like, um, once I add everything, right, I'll have all of this.
Mhm.
And then what I can do is I can start searching. Does it have zero? If it has zero, I just increase. If it doesn't have zero, like kind of like what I just did before.
Correct. Correct.
Um, min is zero. Does it have zero? It does. So min is going to be one. Does it have one? It's going to be a constant check.
Mhm.
It has one, so I'm going to check two. And as soon as whenever I cannot find something, I will return that.
Yeah, that's correct. So actually, this is the solution that they have given. Like,
No.
so
Um,
yeah. Okay, so this is good. But let's say, so let's improvise. So let's say I tell you like you can edit the array, right? You can edit the array. So can you reduce the space complexity too? So the time complexity will be over order of n, right? So at the worst case, you have to iterate over the whole array. But now can we reduce the space complexity also? If we are, allowed to modify the array.
so if we're allowed to modify array, as in like, we can sort it?
Uh, if you sort like the complexity will be n log n, right? So you have to
Yeah.
keep the complexity n and
Oh, time and space
space one.
constant.
Yeah,
Okay. Oof. All right. Time and space one.
yeah.
All right.
But
Because
now
you said that it's possible, it has to be possible.
yeah,
If
it
you
is
said that,
possible.
okay, O of n time, and so I'm moving through one, so I need to keep track of variables. That's a key, or I think. And then O of one space.
Yeah.
What do you
And
mean?
the thing is like you can modify the array.
I can modify the array. Okay,
Yeah.
good to know. So I guess when I'm at three, and the next one is I can send it to its position where it belongs. So
Yeah.
does it make sense? Wait, I don't know. I don't know if that makes sense, but I could technically be like, it's three. It needs to go to 0, 1, 2, 3. Technically, this is where it should go, but I don't know if I need to, this is gonna work. But let's say I'm like reassigning.
Mhm.
If it's 2, and so what happens to the value here? Great question. Um, 0, 1, 2, 3, 4, 5, 6. It doesn't have a home. Um, so 7 cannot be put. It doesn't even fit 7. So what does that tell me? That tells me that we can find something under 7. Well, the return number has to be under 7, right? Because if not necessarily actually. Um, if 3, okay, because this could also be like million, 5,500, and like that's not necessarily going to find a spot in the array. But I feel like to me that shows that I don't know. Doesn't it? I don't know. Am I going on the right path or not really?
Yes, you are.
Okay, so if I were to put a 3, if it fits, it's like cool, and then I check and see if it fits. If it doesn't fit, then my max is going to be, my result is going to be under 7. That's how I know. What happened to this? I'm not really sure. I go here. Um, I guess what can I do? So after I reassign it to 3, I can't find it. I know my result is going to be my less than 7. And then when I go here, I go to 2 and I reassign 2 here, and and then 6 goes to 0, 1, 2, 3, 4, 5, 6. Cool. Um, and 100 is going to be gone. That's for sure. It could be within 6 still. Um, or, but it can't be, it could be 7 actually. You know how I couldn't find, oh, wait, no, it can't be 7. Because 7 is in here. So, but the array is less than size 7. Hold on. Wait a minute. And this will not have negative integers. So 100 is kind of irrelevant. And then when I'm here, this is supposed to be 2, 3 already. And then 0, if I find 0, I just put it where it belongs. And then when I see 1, I put it where it belongs. And the next item that hasn't been touched is index 4. But how would I keep track of that? I guess I think it should have 2 pointers, I think, because alright, if I were to redo this, do I still have some time? Okay, I have some time. Let's say I start both pointers at 3, right? And I'm like, so this pointer is pointing to the smallest index. So SM is what I'm going to call it. And, oh no, what? Smallest index, SI. Smallest index. And then this is just like my little pointer to navigate through the array. So currently the smallest index, or the value should be 0, is what we need. Because it's at index 0. When I see 3, I go to 3, and I make this 3. If 7 doesn't have a home, I don't really care. It just becomes this. And then this moves on here. If 2, I try to reassign. If 6, I guess I'm gonna do some sort of while loop. If this can be rehomed, I'm gonna send it to 6. And this can be rehomed, so I don't really care. Whatever, I just stop. And then this becomes 2, right? And I move here. And then this is in the right place, so I don't have to do anything. This is in the right place, so I don't have to do anything. When I'm here, it's not in the right place, so I check. And if it's replacing my like SI, then I have to move SI by 1. Oh, wait a minute. Yeah. But I need to also make sure that SI doesn't go to the location that has the right index. So this becomes 0. This could still be SI. SI moves for as long as the index is not the value and at the index is not the same as index. So I keep increasing that. So here I stop here because this is where it's like wrong. If this was correct, I will move all the way like down here. But let's say I just moved it up to here. Okay. And I check this and I'm like, okay, 1 is not in the right place. So I'm going to reassign it. SI needs to move for as long as like they're the same, like everything is in the correct order, it needs to move. It needs to get out of here. So this is where it's going to be like, okay, stop. And then I move by 1. This is in the right place, so I don't have to reassign it. And I've reached the end of the array, so I return this index. That's a lot of steps that I just like talked about.
Yeah. So this is a correct solution. So congrats. But I think like you are increasing the complexity with adding si in place. So what you can do is like you can just replace the character like the numbers, right? And then you can iterate once again the array to check like which number is not in the place. So wherever the number is not is equal to the index, and then you can just return it. So it will be again order of an solution itself, but you are reducing the coding complexity of your solution.
Oh, okay. So you're just saying like just sort it, um,
Just put the elements in their place, right? And
and then
discard what you don't need, and then you can just reiterate once you have covered this array again, just to return it. So it will be like a lot easier, maintaining all those
yeah,
pointers
that's
and
a lot easier. Oh,
yeah,
okay, yeah, that makes sense. Wow. Should I try to code that
yeah,
really quick?
sure, sure.
Okay. So, so I'm gonna look through the array first time. Um, plus plus. Okay. So my current, I would just make it create a bunch of variables just to make sure. My current number is array I. This is gonna start off as, oh shoot, I think, I don't know, it was like 3 or something before. Anyway, whatever. What example should I use? Let me just put it back to where it was. I think it was like 3, I don't know,
Yeah, it's
7.
fine. It's fine. It's fine. Uh,
Okay.
Let me just give you an example. You can use this. 2, 3, 1. We can use this and
Yeah, sounds good. So now I have 10. Um, if um, if array at current number is valid, right? Like as if array is less than or because the most it could be is 1, 0, 1, 0, 1, 2, 3, 4. Array dot length -1. If current number is less than array dot length, actually array dot length is 5. So yeah, if it's 4, then current array at current number becomes current number. Oh wait, I need to keep
yeah,
replacing. Okay, wait. Um, so I guess while current number is less than array dot length, um, array dot current numbers becomes current. Well, let temp equals array dot current number, and then current number array dot current number becomes current number, and then current number becomes temp, and then
okay,
I keep doing that. Um, and then I move on to the next. And so this will just kind of reassign their thing, like you said, and then just kind of go through array dot. Well, let me just I less than array dot length. And if array dot I is not equals to I just return I. That will be the smallest, right?
yeah,
And I think if it's not equals to I return I. I'm trying to think, could there be where it matches everything?
yeah,
If I don't return at the end, return array array dot length -1 plus 1. That's the last number.
so
Plus
that is like array dot length itself, right?
yeah,
Yeah,
yeah. So wow. Okay, let me see if that works. Oh no, I think I'm doing something. Current num equals 10.
uh,
Okay, wait.
it,
I think I'm messing up here.
it is actually is
so
undefined. Okay, so
so if temp is while there it's less than thing, right? Current number. Okay, so current number currently, is it 10 less than array dot length, which is 5? No, it's not. So I don't even enter this.
Mm. Yeah.
Um, and then the next number is 2. Is 2 less than array dot length? Yes. So my temp becomes array at 2, 0, 1, 2 is 3. Wait, let me just bring this up here. Hard to see. So I'm looking at 2. Um, Current number is 2. I'm checking to see my temp is 3. Array at 2 is 3. Um, Array current num becomes current num, so this becomes 2. And current nums become temp. This becomes 3. I think this is where I'm like having an issue. Is temp at 3 in the right place? No, it's not. So this is 0. And array at current number becomes current number. Current number, so this becomes 0. Um, and now is current number less than? Yes, it is. Array at current number is 10. Array at current number becomes current number, so this becomes 0. And then my current number becomes 10. This is less than, so I exit out of here. I exit out of here. Oh, and then I exit out of here. And I do I++. So now I moved on to this. If I only enter this if it's not in the right order.
Oh, so
So
actually, the thing is, you haven't put the check
are you
if
trying to say something? I
yeah.
see your lips moving, but
Uh, you can't hear me.
I can't hear you. Oops.
Okay. Yeah, yeah, this one. So it was basically the infinite loop. It was entering into the infinite loop.
It's still having a run on error. Oh wait, array. If array at current num. Wait, if array at current num. No, yeah. If array I is not equals to I, I'm failing some tests. I only have 3 minutes left. Let me see what's going on. So when it's 1, 3, 0, and 2, I'm getting. I expect is 4, and I'm giving undefined. It's doing a run-on error. So if I guess it's the same thing. So I have 1, 0, 3, 4, and I'm getting. I'm failing. By the way, I cannot hear you at all. If you're not talking, it's okay though. No pressure. Yeah, yeah. I think I need to. If current number is not I, Oh, I think it's this. Because if it's the same, I want to stop. Even if it's less than, I need to stop. So I think the while loop check within. Well, current number. I have an extra closing parentheses on 34. Wait. Wait, am I still having an extra closing parentheses? Okay. I'm still failing 3 tests. So I don't have the run infinity loop error anymore, but I'm still like not getting the right answer. So when I'm here, I think I'm returning 0, array dot length. Why is my actual even 0? How does that make any sense? I look through the array. Oh, because I'm returning I. If array I is not I plus, if array I is not equals to, if array of I is not equals to I return.
So
Oh, I
what
need
you
to
can
keep
do
track
is
of minimum.
you can try to print
Wait,
the.
let min. I totally forgot about that point. Um, is
No, no,
min,
it's fine.
return
It's
min.
it's fine. It's fine. So you don't have
If
to
it
maintain
is,
the min.
then min also plus plus. Yeah. What?
You don't have
What
to
the heck?
maintain the min
So,
actually.
are you typing something? I don't see. I'm down here, so I don't see the top anymore.
Uh,
But
can you hear me now?
I'm starting minimum at 0. If let I equals 0, I less than length. If array I is not minimum, I will return the minimum, right? Because if it's 0, it's not minimum. Oh, if it's greater than minimum, I return the minimum. Otherwise, min plus plus. If it's equals, I want it to increase. Yeah. If it's less than, can 0 that be less than minimum? It can't be. Minimum is 0. So it's either 0 is there or not. But let's say 0 is correct and then 1. If it's greater than minimum, maybe?
Um,
So, yeah.
so you can see like 0 is not updated.
Okay. Current num, alright. The heck? So why didn't 0 get started? So when I'm at 0, I'm here. Current num is not equal to I, because I is going to be at 2 when I'm at 0. And current num is less than 0. That's true. Temp becomes, my updated array is 1, 2, 2, 3. And here also 0. My updated array is out of order.
Is it
Okay, I
like
think
a
I'm not updating correctly.
swap
I don't
function?
want to waste more time, and I can't hear you. For you, I'm gonna keep working on it. I can keep working on it, but I don't want you to feel like you need to stick around. So,
Uh,
it's up to you. But I think it's just check the swap method. So my temp becomes array current num. Um, my temp. Okay, so when I'm swapping, all right. So 1302. I'm at 1, and current num is not equals to I. So temp becomes array at current num, array at I, right? Array at I is 3. So this becomes 3. And array current num, so array at 1. So array at 1 equals 3. Array at current nums becomes 1. Oh, oh, okay. So, well, I am only updating one way, no? Current array at current num becomes 1. And then I'm just putting the temp here. So, like,
Oh,
now this becomes from this to, so when I do array at current num, oh, oh, okay. Yeah. Okay, gotcha. Um, so I guess array at temp becomes current num. Wait. Array at current num becomes, so array at 1 becomes 3. Array at I becomes temp equals temp. No. Um, don't I not want to update it because I want to keep updating? Like, so when I'm here, I want to update this to be 1, and I want to take that 3 and do the while loop again and update it to this. And then when I have 2, I want it to be 2.
can
Can you
you
hear me?
hear me now?
Oh, I can hear you now. Yay.
So what I think, like you're losing zero actually. So when you're
Yeah.
updating three, right? So at the third place, it there was zero, and since you updated only single, like one-sided, so zero was lost somewhere. So you have to, replace it. So you have to do like swap both ways. So actual swap, right? Not only one-sided swap.
So I guess where I'm confused is like when I like originally I have this, right?
Mhm.
I want to swap 1 here, but don't I want to put 3? Like, you want me to, should I be swapping each time, both ways? So this becomes array, I becomes temp.
Yeah, you should swap it, right? The reason being because let's say if there is a number that should come at its own place, so it will get swapped later, and the number will be present there. So what I'm trying to say is like if zero is present any time later, right? So it will be getting swapped with its own. In its right place. So if you swap three before also, then also it will be getting replaced.
Mm-hmm.
So the thing is like you are losing zero, right? While
Yeah.
swapping. So that is the thing. So you have to preserve it somewhere. Because
So,
when you are doing multiple hops, right? So then in the second hop, the zero should have come in the second place so that it can be processed. But in this particular thing, like it is not even processed and even once, right? So just try swapping like these, and I think the rest of it is fine. And you don't need minimum
okay,
here.
sounds good.
Yeah, it ran. Yeah,
Oh, I don't need it?
yeah. You don't
Okay.
need.
I
It's
guess if array of number is not equals to,
I then you can just return it. Yeah.
oh shit.
No,
Wait,
you have to return it.
I'm sure you're right. I think the way I edited was incorrect. But okay, thank you so
Yeah.
much. I appreciate it. This was very silly of me. I don't know why. Like the most
Um,
simple swap, I'm like having trouble with. But
no problem. No problem.
thank you for your help. I appreciate it.
Yeah.
Take
Thank
care.
you. Yeah. Bye.
Bye.